Hello, and welcome back to the 2023 Healthy Longevity Global Innovator Summit. I'm Peter Lee, and I have the great pleasure and honor to moderate a panel. And the topic of the panel is on applications of AI, catalyst projects of note. And really, what this panel will be about is to hear directly from a set of innovators that are healthy longevity awardees or in this Catalyst program. And I think it should be something that I'm sure will be very thought-provoking because as I clicked through in preparation for this panel, some of the project descriptions, really some very creative and inventive solutions, and some to my mind, might have really outsized impact on the quest for healthy longevity. But I'm hoping also that beyond the projects, that the journey to get to this point and some of the personal motivations of these panelists themselves might get teased out in the discussion. And so I don't want to steal too much time away from the panelists themselves. And so let me just explain that what I'll do is I will go around the horn and give each speaker about 5 minutes to introduce themselves and offer about 5 minutes of remarks to introduce, what they've been working on, a little bit about their project. After we go through 5 minutes with each, then we'll go through a kind of summary and analysis of Q&A with the panelists for the remainder of the session. All right. And so with that, and I'll leave it to each of the panelists, each of you speakers to introduce yourself before you go into your 5 minutes. And so with that, let me bring Matt Flynn to the floor to get us started. Matt?
Great. Well, thank you so much, Peter, and thank you for the invitation to be here. It's always so nice to see all my friends on the other side of the pond. I'm here in England, but I grew up in Hartford. So I am in a business school at the University of Leicester School of Business in the Department of Work, Employment, Management, and Organization. And a couple of years ago, I was very grateful to have some funding to do some research with a couple of organizations representing military people and looking at the experiences of veterans in transitioning from the military into the civilian world. My interest there was on how people make a successful job transition, especially when it's a very big leap from one occupation and one sector to something else. Often people fall through the cracks, and this was an exciting opportunity to look at something which works relatively well here in the UK in supporting people in making a successful job transition. So when somebody leaves the military, they get an employment coach, they get training, they get top-up training, which they might need, and then they get employers who are members of what's called the Armed Forces Covenant, which are veteran-friendly organizations. The big barrier that veterans have in making that transition is around language, how they can translate the very good skills that they have that they acquired through the military to something that they can do in the civilian world. And where people fall down, it's usually because of a miscommunication between the two sides. I'll give you a very good example of this. A survey that we did as part of this project was asking first veterans, what are the big skills, most important skills that you have to offer civilian employers? And then we asked civilian employers, what are the skills that you're most looking for? So when we asked the veterans, the big thing that they said was leadership. I've got great leadership, especially the officers. But then when you ask civilian employers, really leadership came maybe fifth or sixth down the line of importance. And that doesn't mean that their skills aren't important. It means that it's difficult for them to translate that language. And thinking about the subject of today's session, I think AI could play a very important role for older people, especially when it comes to job transitions, in better marketing themselves to employers. And employers can do a better job of finding that pearl within a haystack, or sorry, the pin within a haystack for somebody who might be very successful, but might not be an exact face which fits the job which they're posting. So I'll leave it there. I know that I've only got about 5 minutes, and I'll give some time to the next people.
Well, thank you, Matt. That was really perfect. And I was taking note myself of several follow-up questions. But as you say, we'll give everyone else a shot first before we return to that. But really fantastic and provocative. But let's go ahead and move then to our second panelist, who is Ram Gorapati. Ram?
Thank you. Thanks for having me. I am an assistant professor in the Department of Biomedical Informatics at the University of Utah. And I specialize in developing informatics methods for exposure science and health and for translational research. And the work I'm briefly talking about here is done along with my colleague, Dr. Julio Faccioli, who's a distinguished professor also in biomedical informatics. The premise of what I am going to talk here, what I have here, the project funded by NAM, is to understand the effects of aging and exposure and the interconnection of how these two factors might lead to well-being, disease, and progression in life. We know that exposures have effects on biological pathways, both mutagenic and epigenetic. We also know that with age, we have a reduced reserve capacity to deal with exposures, with effects occurring at the cellular level all the way up to organisms levels. Now, what we don't really understand decently well is the effects of concurrent and intermittent exposures over the course of a lifetime, and if at all, what they might have in aging and age-related disease. And to understand that, we use the pragmatic framework of the exposure, but the difference is most work, the exposome, most work dealing with the exposome at this point is mostly concentrating at the young age, because it's much easier to construct the exposome, even theoretically, for children, because you have a trajectory of where they were, what they were doing, and potentially can put together a record of such exposures. But when we are talking about the elderly, we don't necessarily have such records. And we need to use various big data methods and AI methods to see if we can even possibly construct such a record. And then if we can make such a record, we can potentially combine that with clinical data or any other data to understand the effects of exposure on aging and aging on exposure. So essentially the challenge here is when we don't have data, how do we, for such a record of exposure, how do we create that? And can we come up with a conceptual framework that can be used for generating such records of exposure? Now, when in the absence of real data, we go and try to see if we can simulate or predict or computationally model such data. And we looked at potentially using some of our previous work in trying to develop location and activity trajectories of individuals as they live in a certain area and move in and out of a certain area, and we developed a agent-based model called STAM, or the full form of that is spatiotemporal human activity model, which works with decent accuracy. We were able to, at least for people living at in Utah, we could say where they are at a given point of time, and all of this was developed using completely publicly available data. So you give a particular, if you know of an individual of a particular demographic, we could say where they were using, and the model was developed using all publicly available data, the American Community Survey, census data. And so the idea is now, can we go more back, more historically, to see if we can create such records of exposure. Also, as a preliminary step, we looked at to see if there is any association between exposures and disease of aging. We used a time series method called shapelet-based analysis to see, and we did find some level of association and a general trend between air quality exposures and Alzheimer's, COPD, stroke, and Parkinson. I'll end there and answer any other questions during the
Great
discussion time.
Yes, and really interesting. And again, I was taking some notes here, and so I think there are some questions, because I think much of what you're doing really touches on some of the real world aspects of this general concept of biological aging, and so we'll want to get back to that. But again, we're only halfway through these opening remarks, and so we'll move on now to Bianca Migliori. Bianca?
Thank you, Peter, and thank you for having me. My name is Bianca Migliori, and I'm a principal scientist in data science at the New York Stem Cell Foundation, specializing in computer vision for pattern recognition in large-scale high-content imaging screens. So at the New York Stem Cell Foundation, we are focused on trying to find cures for the major diseases over time using stem cell technology and cell technology. And what we thought for this project is, like, since many of those diseases are actually age-driven, so the onset is related with aging, what if we try instead to characterize what an aging cell look like and then try to revert the phenotype and make it aging less fast or slow the aging down? So to do that, we leverage our unique capability to produce very consistent and large data sets, and to draw from our biobank to expand the number of donors that we have to create these imaging screens, which we then analyze using machine learning. So what characterizes the images is that they are labeled with very generic compartments. So basically, we use an assay that only looks at nothing specific to aging, because we wanted to be unbiased towards our results. And then, as you can imagine, we produce millions and millions of cells for each screens, resulting in terabytes of data. And most of these differences between young and old are actually very subtle. So not even an expert would be able to distinguish between them. So what we did was to develop an algorithm to be able to distinguish between young and old, not only in a categorical way, but also linearly. And what we are aiming to do is, of course, gaining information from this. So reverse engineer the algorithms to try and understand what feature exactly is driving the decision process of the algorithm, and also ultimately using drugs to try and revert this phenotype. So what if you expose the same cell to this model and then inspect whether this cell becomes younger or older depending on the drugs you're testing using these drugs? So can we then find some cues into what is the pathways that are aging in a cell, and what are the features that are aging, so that we can gain this information to try and reach phenotype.
Really interesting. And just as someone who next month is going to turn 63, I have a personal interest in these things. One thing I think, as we think about the discussion here, the connections between what you're doing and what Ram had described, there seem like there could be some complementary data sets that get generated, and it makes one naturally wonder if there are synergies that are possible. But again, I want to make sure that we get through all of our speakers before we get into that type of discussion. And so we will move on to Marco Vismara. Marco?
Yeah. Hello. Thank you very much, Peter, and congratulations for the excellent talk you just gave. It was amazing to listen to you. My name is Marco, and by training, I'm a medical doctor, and I'm a specialist and PhD in medical genetics. And I'm here to present because along with my company, which is called Light Science, we were among the finalists of the EIT InnoStars Award. And I want to thank the EIT for the outstanding opportunity they gave me of being here. Thank you. So the aim of our company is to realize a novel method to test blood wherever there is an internet connection. And we can do this leveraging on an old technique and some brand new computer science tools. The old technique is the near infrared spectroscopy, which is known since the very beginning of the 20th century. But because of the physical property of this optical window, has not been used that much. And why? That's because there is a definitely bad signal to noise ratio into this window, because it's the window in which the overtone lies, and so it's stuffed of data. Almost every information about a chemical compound sits there. So it's like quite impossible with the regular approaches to solve this puzzle. So what we did is it was to use artificial intelligence, and by the way, machine learning techniques in specific, to solve this puzzle and to extract the knowledge we want from this puzzle and fruit salad, let's say. This to say that that is something that has been done by colleagues biologists, but our methodology innovation was to go for an hardcore computer science approach, and so that instead of trying an algorithm and check if the results was good enough, we used the funnel approach, in which we let the computer develop every known algorithm, a model with every known algorithm, and then we funnel it down to the most sensitive and specific in order to get the best results. And this had been applied to a solution for chronic kidney disease. Chronic kidney disease is a condition very, very specific and that has two main pillars. One is the fact that affect a lot of people, 1 in 7 adults in US, for instance. And the other very important thing is that the 90% are not aware of patients are not aware they are affected. So this to say that we use our technology not for the diagnosis of this condition, which is done by regular biochemical assays as the creatinine, so something every one of us did in our regular yearly blood work, but measuring phenylalanine in people who is affected. Why? Because this correlates with the protein intake. And this is very important, because think if I'm going to have my yearly blood work done, and I have a star in one of the many lines, and then after 3 months I repeat that line and there is a star still, I will be positive, and my kidney were going to broke. So what I can do is smooth the collapse of my kidney and avoid the fact of undergoing dialysis or transplants, which are not the, either on a personal point of view and on a public health point of view are something that should be avoided. So this to say that we designed this system to help people to manage this condition, which is the most of the time unknown but affect a lot of people. And we do this with this physical technique of the near infrared spectroscopy and the machine learning boost to interpret the data. Thank you, Peter.
Yeah, thank you, Marco. It's amazing and surprising to hear about the use of infrared spectroscopy. I don't know that I've heard that term in many years, and it makes one wonder if there are other modalities of measurement that have been considered obsolete that now can be given new life, given tools like machine learning. So really very, very, very interesting. Okay, so we do have some questions coming from the audience, but I'd like to take the kind of moderator's privilege and start with first a couple of my own. And I do have some questions that are specific to each of the four speakers, but I thought maybe the best thing to do is to start with general questions that all of you could address. It's, of course, very interesting to me personally to see the use of machine learning and its influence on all four of you. And one of the things that, of course, that seems to come out is that the specific types of machine learning technologies are really what I would call, what I've now come to call narrow AI. Those are machine learning algorithms that are used to do specific types of data analysis, maybe some prediction or description type of process. But of course, we now have this newer generative AI that's emerging, and and we're all a little bit struggling to figure out whether it also has some potential uses. So if I'll start back with Matt. If you could comment briefly, first off, on what has been the most important aspect of AI and machine learning in the work that you've been doing to date. But then, as you look forward, do you see obvious roles for this new breed of generative AI in your work in the future? So, Matt, let's start with you.
Thank you. I guess I'm a little bit in the minority in this group, is in that I come from the social science field, and where I see AI the most potential is in terms of language and discourse and some subtext. So I just had a conversation the other day with a colleague of mine. We're developing a paper looking at employer and trade union responses to ageism in the workplace. And one of the difficulties that we have is trying to unpick what's under the hood when somebody talks about older workers, either from business or from labor. So, for example, somebody might give an example of an older person who's in a role. They say, well, I know somebody who's 90 years old and they're still in work and God love them and they're having a wonderful time. And you might think, well, this is an example of how people can just work until, into their 90s. But really, it's an example to show the exception, which doesn't fit the rule. Somebody's in their 90s, they're still in work. That just shows that the other 99% of society probably couldn't be in that role for much longer. And we were discussing how AI could sort of unpick this and look at the language people are using and say, well, is this something which is challenging ageism, or is it really reinforcing the status quo? And I think there's some real potential on the social sciences side to use AI in that way, to give that. I think, Peter, you used in the last session this term of getting a second opinion from AI, and this might be a good way to do it.
Yeah, that's really a good point. I remember there was a submitted manuscript to a medical journal, and we had GPT-4 look at it, and the paper was on the subject of a disease called primary ovarian insufficiency, or POI, but the submitted manuscript had used the term POF, primary ovarian failure. And interestingly, GPT-4 objected to the term, saying that in modern medicine, tried hard not to assign terms like failure to disease states, particularly disease states that might affect minorities or women. And it's an example of the kind of detailed kind of critique and analysis that the editors of a journal could choose to ignore, but it provokes just that extra little bit of thought about things. And with respect to aging and ageism, you could imagine the similar kind of analysis. Very interesting. Ram, what about you? So narrow AI and now generative AI. How do you view it all?
So, so in a sense, not actually what is now called defined as generative AI, but using what is more classical at this point of time, what we are trying to do is to generate new data from available data sets. So that way, I won't call it generative, but at least generation of data sets. But I think a place where, in my field, where I see generative AI very useful is potentially in creating a conceptual summary of data so that it can be used for integration. There are like recently some derivatives of LLMs in trying to create conceptual graphs of existing data. And then if you have a graphical representation, you can then easily combine graphs and in turn data that can be used for any kind of analysis. Like in the project I was mentioning, want to look at avenues where we can combine new types of data that can be used to create exposure profiles when there isn't existing data. So it is, haven't yet explored that area, but I think there are opportunities in that space.
Yeah, really, really interesting. We've been puzzled at Microsoft Research about what in computer science we refer to as causal graphs. So it's just the graph of points that are known to be direct cause and effect pairs. And oftentimes, when we're trying to use any type of computer analysis to analyze, engage in causal reasoning, the first step is to draw out that causal graph. And it's always been a manual process for us. You get experts together to do this. And so it's interesting to hear your thoughts there on the possibilities that maybe some elements of that step could be aided through AI. So very interesting. And as I mentioned before, after we heard your opening remarks and Bianca's, there seemed to be some potentially complementary aspects to the data sets. So that's a subject I won't get into, but let's stick with this question about traditional and generative AI now, moving to Bianca.
So in my field, or what I'm trying to do, I think AI was pivotal because, originally what I'm trying to do was performed maybe, with 2 or 3 samples and trying to see differences in known phenotypes and trying to understand or have a clue of what was going on and then trying to find differences. While now, what we can do is to do it at a completely different scale and level, meaning that we can do the other way around. So trying to guess what is changing based on unbiased models. So this is a completely new thing that is going to give a lot of insights about our data sets. And also the scale. So another thing that came up during our research is that there is a lot of fingerprinting. So it's very easy to identify single donors. So it's very important to make sure that whatever we are trying to capture is not just nuance or not just donor to donor variation. And then when you scale up to try and identify what is in common with these donors that belong to the same class, then you do really need AI. So there's no way you can do it with other tools. So I think AI in this field is just something that is going to, and it is actually picking up a lot, and a lot of researchers are turning to AI for so many things in this field. In terms of generative AI, I think what happened with ChatGPT and the other generative tools, it's like also revolutionary. Like everything is changing so fast, and I'm just look forward to see what this will bring further. But I already see, like, again, in my fields, what we're trying to do is to see what is specific of this cell for it to belong in this class, which could be either aging or a drug application. So if we one day would be able to use generative models to actually predict how your cell would look like, since every cell or every donor is so unique, that would be a game changer. And also, like, saying, like, you're a young cell, how would it look when you're old? Then maybe we can pinpoint what kind of disease you might get when aging. So we could be able to maybe like try to slow down the onset, or try to cure them before it happens. So I think the possibilities are really endless.
Yeah, they're really interesting. And so now maybe I'll give myself a chance to make a comment about the data that you work with in RAM. And it's a fairly abstract thought, but one of the examples, one of the projects that we had before the pandemic at Microsoft Research jointly with the Providence Health System is helping them fill out the forms for doing the required reporting for cancer patients to state cancer registries. And so Providence, across their 50 plus hospitals, I think more than 20 cancer centers, they had this problem of having to do reporting to 7 different state cancer registries. And this was a labor intensive thing where they had clinicians, doctors and nurses spending several hours a day, maybe 40 of them spending several hours a day reading through these unstructured notes on the cancer patients and then extracting information to insert into these 7 different forms. And so this was an area where we used machine learning to try to automate some of that process. And it was quite a lengthy project for us. What we discovered, though, just a few months ago is that GPT-4 and probably other large language models like it were able to read the same unstructured clinical notes and generate label training data to train machine learning to do that task. And so the idea of generative AI as a way to prepare and label data for training machine learning specific tasks has arisen as a kind of major opportunity. And so as I was sort of connecting the dots here, it made me wonder whether some of the data preparation for machine learning and labeling for machine learning, which can be very difficult, might be feasible by possibly connecting some of these data sets.
Yeah, that would be actually a really good solution, because of course we are very familiar with this struggle. Even for like smaller things, like, since we have to be mindful of all the possible confounders, we need to be very aware of ethnicity and sex and other kind of things. But ethnicity, like most of the times in the older forms, there were like 4 major ethnicity groups, which is not reflecting what the population is. And this is just not right. And whenever you go and train a model, you have just labels that are not reliable. And as you said, like, we have to report the types of diseases that people have. And it's just like, it's never black or white, right? You can have a lot of different things that might be more or less impactful on what you're doing. And the way they are reported is crucial to really determine that. And still, we are trying to automate or come up with better solutions, but this is a very big struggle for sure.
Yeah. Ram, does that make sense to you, or do you have other thoughts?
Nothing to add right now, but I completely agree with both you and Bianca.
Yeah, very good. All right, and now Marco, traditional machine learning and generative AI. Do you have thoughts to share? Marco, are you there?
Oh, sorry. I
Ah,
thought were going to activate my mic.
uh-huh.
So, thank you for the question, and it was a very interesting debate. And what I want to add is the fact that we have to interact with humans at the end of the day, and all the fancy technology stuff is useless if people doesn't comply with our suggestion and perform something in our specific case, for instance. And so I think that LLM and generative AIs would be groundbreaking because we have experience already that if you help people and you talk with them, you explain, you give constant feedback, they will behave differently. And so I think that not only the labeling the machine learning data set in order to obtain a better machine learning model, but also the other way around, meaning with machine learning, we can analyze signal and so on, but with the LLM, we can deliver human readable and actionable results, which could lead to a major impact.
Yeah, fantastic. And you know, it's sort of the flip side of what I described in my talk about helping doctors talk to patients. But there is something, you know, oddly, you know, Judy Faulkner at Epic, their company has been experimenting with this, and they're in early deployment. And what they found is that that patients actually find the AI generated communications to those patients to be more human than the ones generated by doctors. And of course, they aren't more human, but I think the doctors are so busy. I think that they can't take the time to put that extra personal touch. And I think you're putting your finger on another aspect of things, which is, you know, what will actually be the most understandable and acceptance kind of providing kind of feedback. I want to give a chance for this question from the audience. And so let me read it and then just invite any of you to jump in as you feel. The question is, the most interesting use cases for AI Copilot support involve feeding potentially proprietary or confidential information into the system. Are there opportunities to build private closed system accounts that better protect privacy? And so I think this is an important question, and it's a question that I hear a lot, which are the concerns about privacy and what is being done with the data. And so actually, let me go ahead. I'd like all four of you to respond to this. So let me start with, again, with Matt. Matt?
Yeah, again, coming from a social science point of view, it's quite a challenging topic when you're dealing with sensitive issues. In this case, joblessness and experiences in the job market, in protecting privacy and having informed consent. I guess from my perspective, the most important aspect of this is having informed consent of those participating. Sometimes people might be very happy to have their personal experiences input as long as they can see that they get something out of it. And sometimes what they get out of it is a feeling of satisfaction that they've made lives easier for people who are on the same journey as they are. So if there's an element of co-production, it can be quite helpful.
Yeah, very good. This idea of informed consent does seem to be something that I wonder if it will come up even in the NAM Code of Conduct initiative. It'll be very interesting to see how that plays out. It does seem like a key point. Ram?
So I think the ethical aspects of privacy is a thresholding factor depending on I think like Matt mentioned at some instances people are willing to share, at sometimes not, and depending on the use cases, at least I'm looking mostly at a population level. There are a lot of useful endeavors that we can pursue without having uh, any level of identification of individuals. Like the agent-based modeling I was mentioning is completely de-identified data available publicly. Anybody can download it. However, one of the things that we found that is if our behaviors change due to whatever factor, like what publicly available data that is available through the census is usually factored for normal times. The American Community Survey, people are saying what they're doing at normal times. But if you try to use such inputs for modeling something, let's say during the pandemic, we are going to get results which are way off. Then you would want to look at, can we obtain data which is, if you want to try to understand behaviors of people moving around, maybe then we want to look at more dynamic location trajectories, maybe using cell phone signals. So depending on the need, there's a threshold of privacy.
Yeah, and do you also think then in those situations also about informed consent kinds of mechanisms, or what what are there workarounds?
So informed consent, yes, if an individual level studies work, we're doing at an individual level, yes, but at a population scale, if you're looking at a whole,
right.
it's not technically feasible to get everybody's informed consent. And if there are records that you can obtain, yeah, then we have to go around informed consent.
Right. Bianca, any thoughts from you?
Well, yeah, we also luckily have, I mean, being part of like medical research, we have many systems in place. So we have both informed consents and also de-identified donors. So, I mean, everything is encrypted. Everything we do, for instance, on the clouds is encrypted. So we are very careful about that. Of course, every donor that comes in to donate their materials to science needs to find these consents, and they also specify what they want it to be used for. So it could be just like local research, or they could be willing to share the data to other entities, which we tend to do, and they tend to agree to. But yeah, I mean, I see that this is a very hot topic, and it's something that needs maybe some more attention most of the times, or sometimes. But it's also true that with AI, or the biggest advances are actually coming with more data. So it is important to be transparent. It is important to like de-identify as much as possible, especially, I mean, in medical research for sure. And de-identification is key, and consent is key. But also for other fields, transparency, I think, will help a lot, both progress and the people that are giving away their data.
Yes. Instantly, this reminds me, listening to all three of you, we'll get to Marco in just a minute. We've done experiments with GPT-4 to present it with access to a bunch of patient data, and then we explain we want to do some analysis of the data, but under no circumstances should you violate HIPAA. In particular, do not expose the protected health information of any individual. And GPT-4 responds in a way that seems to indicate that it understands that directive, but it can still be relatively easily tricked into leaking someone's personal health data. And so it doesn't appear to be quite intelligent enough. It seems intelligent enough to understand the concept of patient privacy and HIPAA, but not intelligent enough to resist a determined human being from tricking it into exposing. And so, getting back to Victor Zhao's question earlier, we don't know if in the future AI systems will get smart enough to do that. Let me now go to Marco on this question about narrow versus general AI.
Sorry,
Marco?
this last privacy thing.
Yes.
Yes, about.
Oh, I'm sorry. Yeah, privacy. I'm sorry. Yes. Yes.
Nothing. What I want to point out is that is important the informed consent is even more important an open code of conduct which states clearly what are the aim of the data we gather, but most of all is important to be not hypocrite. And sometimes I don't want to say people cheat, but they forget about some new evidence. I remember a paper from some years ago in which they found the single individuals from metadata from mobile phone, but still at the present day, years after this paper, people say, yeah, we will collect anonymous metadata. But this, I think, it's what I would not define as integrity.
Yes. Yeah, really well said. And that's data can live a long time. And so the data and privacy risks can live a long time. We could go for another hour here, but unfortunately we're running out of time. And in fact, we're out of time. But what I'd like to do is just very quickly just go through all four of you again. If you can, if you have just one bit of advice or guidance that you would provide to your fellow researchers in this Catalyst program, or others, anyone, in fact, who is exploring the use of AI in their work, if you have one bit of guidance or advice to share, feel free to share it. If you don't, that's fine too. But I just wanted to close off with that. Matt, we'll circle back to you on that.
Okay, thank you. I guess the one word would be co-production. If you can work with people if research is with people rather than about them, then they feel more involved and they feel more comfortable in making the journey with you.
Great. Ram.
Following up on the last question and what Matt just said, I think potentially using something like a blockchain technology for storing and managing data, and let the people decide on what they want to share about themselves can be potentially what can inform consent and ethical use of data in AI.
Fantastic. Bianca.
Well, I'll focus more on AI itself. I think it's very important to be mindful of your data and not just blindly apply a machine learning model to your data, because you will always find something, but be very aware of the meaning of the result, and then make sure you don't have any confounder or anything else that is driving the decision process before thinking you actually found something.
To you.
Hello?
Yes. Hello.
No, sorry. There was a bit of interruption. I appreciated Matt one-word approach, and my word is memory. Because, as I said, near spectroscopy is considered to be an old technique, but with the new AI capabilities, we had the chance to create something new and hopefully impactful. So my word is memory.
Great. Well, fantastic. Really, I learned a lot listening to all of you. I hope the audience did too. Thank you all, and congratulations for all the great work and accomplishments so far. And I'm sure there's even more and bigger stuff coming. So with that, we will wrap it up and turn it back to our host overlords on this day's session.